All right, so to finish out this semester, we are going to find cross products. So when I'm finding cross products, remember that dot products will kind of sort of help us find orthogonal. It deals with orthogonality, which is the way we say perpendicular. Okay, so in space, we're going to change that to the word normal. So if I have a vector that is normal to another vector, that means I'm floating around in space. So I could have this vector, and I could have this vector, and they'll make 90-degree angles with one another. Okay, I can also have it normal to the plane. So just like 2 points determine a line, okay, I can have two vectors or two lines determine a plane. So two vectors will be in a plane. And I can find a vector that is normal to that plane. So what we want to do is just look at the cross product. I'm going to do a couple examples with you. And it's pretty straightforward. So if I have v, vector v, is going to be 3, -1, 2. And then vector w is going to be 2, -3, -3. Okay, so the cross product is going to return a vector that is orthogonal to both of those, that is normal to the plane that both of those are in. Okay, so the first thing you want to do is right across the top, we're going to do an I, a J, and a K. And you're going to do this every time. The first, sorry, I should probably tell you what we're finding. We're going to find this. Okay, so this is the cross product of vectors v and w. And because we're lazy math people, we're just going to say the cross of v and w, or v cross w. Okay, so what we do is make sure v is first. So I'm just going to use its coefficients. So I've got a 3, -1, 2. So 3, -1, and 2. And w is second, so put that on the third line. So your first line, second line, third line. So I've got 2, -3, -3. And since the cross product returns a vector that is orthogonal to both of these and is normal to the plane that both of those lie in, what we're going to do is harken back to taking discriminants. So if you took discriminants in algebra, then you'll remember that to take a discriminant of a 3 by 3, basically what we're looking at is, it's going to be easier if I just say it this way. If I want I, I'm going to cover up I, okay? And then I'm going to take the discriminant of what's left. So the discriminant of the blue stuff. And so I'm going to cross multiply and subtract my differences. So I'm going to write out the first couple, and then we're just going to do it in our heads. So the discriminant is going to be -1 times -3 minus -3 times 2, and that's going to be on I. So if I want I, cover it up. So now I want J. Now, J is going to be a weird one. You've got to change his sign. So I'm going to subtract, and I'm going to write smaller. 3 times -3 minus 2 times 2. And that's on J. So notice I subtracted here. So whatever this generates, change its sign. And then if I want K, cover up K. So plus, good heavens, I need to write smaller. 3 times -3 minus 2 times -1. And that is on K. So the cross of V and W comes back as -1 times -3 is 3, minus -6 is 3 plus 6, which is 9i. Okay, minus, and then 3 times -3 is -9. -9 minus 4 is -13. So minus a -13 turns into plus 13. And then I have 3 times -3 is -9, plus 2 is -7. Okay? So that's negative 7. So I have negative 7 on K. All right, so now we're going to do V cross W. So I just did that. W cross V. Okay. So what I have is, I'm going to flip-flop what I just did. So I've got an I and a J and a K. Okay, so this time W comes first. So I've got 2, negative 3, negative 3. And then V comes second. So 3, negative 1, 2. Okay, you cannot see. All right, so for the first one, I'm going to go ahead and do the multiplication this time. Okay, so the first part is going to be if we want I, cover I up. So cover this up. Negative 3 times 2 is negative 6. Minus negative 1 times 3 is negative 1 times negative 3 is positive 3. Okay, and then minus. Remember, always subtract your J's. So 2 times 2 is 4. Minus 3 times negative 3 is positive 9. Okay, and that's on J. And then for K, I've got 2 times negative 1 is negative 2. Minus 3 times negative 3 is positive 9. And that is on K. So when I clean that up, you will notice that I get a negative 9I. And I get a negative 13J, and I get a positive 7K. So it's the same vector, it's just pointing in the opposite direction. So instead of being a vector this way, it's going to be the same vector going that way. So your initial and terminal points flip-flopped. Okay, so let's try another one. Let's do the cross of V and V. So I know that that is going to be, remember your I's, J's, and K's. So I, J, and K. And then I'm just going to repeat V. So 3, negative 1, 2. So 3, negative 1, 2. 3, negative 1, 2. So if I want I covered up, so negative 1 times 2 is negative 2 minus negative 1 times 2 is negative 2, so minus a negative becomes plus. Change your sign on J. You can all see what I'm doing. Okay, so I get a 3 times 2 is 6, minus 3 times 2 is 6, and then plus, if you want K, cover it up. So 3 times negative 1 is negative 3, minus 3 times negative 1 is negative 3, so minus a negative becomes plus positive. So what you end up with is 0 I's, 0 J's, and 0 K's. So you have the 0 vector. So if you think about that, you're looking for something orthogonal to both of these, which is just itself repeated, and it's going to be normal to the plane that this is in. Well, there's an infinite number of them. This vector is in an infinite number of planes. Okay, so it returns the 0 vectors. So your cross product on the same vectors will always be the 0 vector. Okay, so I have, let's do 1 or 2 more so you can actually do those. We want to find the area of a parallelogram given that I have, hang on, P1 is going to be the point 1, 2, 0. P2 is going to be the point negative 1, 7, 3. And P3 is going to be the point negative 2, negative 1, 2. So basically what we have is I'm told that the corner of this parallelogram, and I'm not even paying attention, so I may be drawing these backwards, but the corner is going to be at 1, 2, 0. And so P1, and then I've got a vector to P2 and a vector to P3. Okay, and if you look at that, that makes a parallelogram. So if you want to find the area of a parallelogram, we're going to do the cross product of two vectors and then find the magnitude of the resulting vector. So first of all, we got to set these up. So I need P2 minus P1. Okay, so my first vector, which we will label as this is vector V, and this will be vector W. Okay, so vector V is going to be -1 minus 1 is -2. Okay, 7 minus 2 is 5, and 3 minus 0 is 3. So this is -2i, 5j, 3k. Vector W is going to be, ignore this one because he's in the way. So I've got -2 minus 1 is -3. -1 minus 2 is -1. 2 minus 0 is 2. Okay, so those are my two vectors. So there's vector V, there's vector W. So I need to find their cross product and then find the magnitude. So the magnitude of the cross product of V and W will give me the area of a parallelogram. Okay, so find their cross product first. So I've got an I, a J, and a K. So V comes first, not that it matters because think about it for a second. If W comes first, it's just going to be the negative. You're going to negate the vector, and then the magnitude will be the same because it's the same vector. It's just pointing in a different direction. Okay, so I've scribbled. All right, so my I is going to be a -2, 5, and 3, and this is a -3, a -1, and a 2. So if I want the cross product of this thing, so first of all, let's do the cross, and then we'll go find the magnitude. So if I want I covered up, so 5 times 2 is 10, minus -3 is 13. Okay, if you want J covered up, and remember to change his sign. So -2 times 2 is -4, minus -9 is going to be +9, which gives me 5. And then change his sign, so it's -5. Okay, and then if I want K covered up, so -2 times -1 is 2. 2 minus -15 is 2 plus 15, which is 17. So that's my vector. That's the cross product. And now we're going to find the magnitude. So the magnitude of this vector is going to be the square root of 13 squared plus -5 squared plus 17 squared, which is going to be 13 squared plus 25 plus 17 squared is 43. So 483 square units is what we have for that little shape right there. The last one that we're going to do is going to be the area of a parallelepiped. Okay, all it is taking, so you can see where I kind of sort of drew the face of this is a parallelogram, and then we're going to have some depth to it. So it's kind of going to be a rectangular prism like a shoebox, but it's going to be pushed over on the top. And I want to know what the volume of the parallelepiped is. So I know that the volume is going to be the cross between A and B. And then find that vector and do the dot product with C. And then I'm going to take the the absolute value of that. Okay. So the volume of my parallelepiped is the absolute value of the cross of A and B and its dot product with C. So if A is given as 3, -3, 4, and B is given as -1, 4, 1, and C is given as 5, -4, 2. Okay, so the first thing I need to do, order of operations says work from the inside out. Okay, and it's not going to matter how you do this because it's going to return the same answer. So it doesn't matter what I ascribe to be A or B or C as long as I'm consistent throughout the problem. So I want to find A cross B first. And so knowing that, I've got an I, a J, and a K. So my I is going to be, if A is first, I'll have 3, -3, 4, and then a -1, 4, 1. So if I want I, okay, cover it up. So -3 minus 16 is -19. Cover up J, but remember to change the sign. So 3 times 1 is 3. Minus -4 is 3 plus 4, which is 7, but change the sign on J, so it's -7. And then K, 3 times 4 is 12. 12 minus 3 is 9. So that is the cross product. And now what do I need to do? I need to take the dot product with C, and then we're going to take its absolute value. So C is 5, -4, 2. So how do I do a dot product? I multiply corresponding components and then do what the signs say to do. So I get a -19 times 5 is going to be -95. -7 times -4 is +28. 9 times 2 is 18. And I need to take the absolute value of that answer. So -95 plus 28 plus 18 is -49. So the volume of my parallelepiped right there is +49. And that is pre-cal.